looks like from that window. All right, let's, this is Stephen McCord. Maybe you can see my picture there. Thanks everybody for joining on time, or at least you do. You have, we're about to hit 50 people and more will keep joining, but hopefully that won't be disruptive. This is the first in a series of webinars that Calms is hosting. And I've been part of the webinar committee, whatever, for a few years. So I took the first one on. So it's the first one of the season. And at the end of this, we can touch on the other ones. But before we get started, let's do a brief message from our sponsor for this one. Ben, you want to pop that up? And then I can introduce Sarah and go from there.
Good afternoon. Hello, my name is Michael Fundman with YSI. We're sponsoring today's webinar series. And so I'm going to give you a quick presentation and I'm going to jump right into it. So I want to tell you a little bit about a white paper we did titled High Resolution Mapping of a Harmful Algal Bloom. I'm just going to give you a 5-minute quick summary. At YSI, we're known for our water quality sondes. Many of you might be familiar with the EXO sondes. We also put these on vertical profilers as well as a number of vehicles. Today, I'm just going to focus on this underwater autonomous vehicle, the EcoMapper. The EcoMapper is a multi-sensor AUV, which means it's an autonomous underwater vehicle. This particular one had a photosynthesis package, as we like to say, of an XO1 on the nose cone. Just a little quote from the PI, Dave Karen: if we can tie these disparate pieces of information together through space and time, it will provide unprecedented information on the succession and trophic interactions with the plankton of Clear Lake. Some of the study objectives, we're trying to link water column structure with the plankton community via discrete water samples. And real quick, we just had 2 spatial scales. We had a large scale and a fine scale. Part 1, the large scale, basically these long undulating missions. This particular one in the upper arm was 12.5 kilometers long. It accomplished that in 2 hours and 42 minutes, and it's undulating the entire time, completely underwater. At the end of the mission, when it surfaced, it was 12 kilometers away from its start position, and it arrived only 23 meters away from its intended endpoint, which I think is incredible, very reliable, very precise navigation underwater by this thing. And just a quick look at results. This is the chlorophyll plots. The blue on the Oaks arm is going to be the highest concentrations. And then in the upper arm and lower arm, we had lower concentrations. With those long range missions, we can plot on these nice looking graphs. So we have the upper arm, the Oaks arm, and the lower arm. And you could see the upper arm was pretty well mixed. Not a lot of heterogeneity. It's very well mixed. In contrast, the Oaks arm, if you look at the dissolved oxygen and the chlorophyll plots, it's not quite as well mixed. Not as much wind is driving mixing in those areas. And moving on to the second part, the finer scale, high resolution mapping. So a lot went into this particular mission. So it was not only the EcoMapper, we are also using drones and spot sampling to determine species at these specific locations. To use the drone, we were interested to see if these accumulations of cyanobacteria indicated any water quality parameters beneath. And so here we can see some lines of microcystin blooms. And going on underwater, the EcoMapper did this lawnmower type mission. And basically it goes back and forth just like you would mow your lawn. And in the end, we have some beautiful plots here. So we have dissolved oxygen, depths, and blue-green algae. Basically, we could say cyanobacterial biomass does not appear to exhibit the degree of spatial heterogeneity often observed at the surface. So no, even with the drone imagery, there's not a lot you could tell about underneath, despite seeing those big clumps of growth at the surface. So if you want to learn more about this, you can search for our white paper, or we have a 1-hour discussion on a webinar we did with Dave Karen. So if you search YSI Clear Lake, I think that should bring you to the right place. And once again, my name is Michael Fundman. My colleague Tim Finnegan is really the EcoMapper guru. So if you want to reach out to either one of us, here's our contact information, and enjoy the rest of the webinar. Thank you very much.
Great. Thanks for that, Michael. And I see a future social media influencer in your career there. And also, Dave Karen, I see you're joining the call, so thanks for sharing that work you're doing. And Ben, this is recorded, right? Is that that red icon in the upper left?
Yes, that's right.
Okay, great. So the contact information at the end there, you'll be able to see. And also, we'll post a recording of this webinar afterwards. So don't worry about taking detailed notes if you want to watch it again. All right, so let's go ahead and get started. Sarah, you can go ahead and try to share your screen there. And let me introduce Sarah Ryan. I've known her for many years. She's worked since 2001 with the Big Valley Band of Pomo Indians in the Clear Lake area, bringing tribal data to bear on policy development and natural resource management. She has a BA in government from the College of William and Mary. So not a technical background, but she certainly picked that up since then. Is environmental director for the Big Valley EPA and co-developer of the Clear Lake Cyanotoxin monitoring program, which she'll present about today. She also co-chairs the California Cyanobacteria Harmful Algal Bloom Network, which several other CALMS members are part of, if I believe. And as representative of the tribe, she works closely with the Central Valley Regional Water Board and US EPA Region 9 on water quality and natural resource protection issues. She's created and leads the California Issues Work Group at the US EPA Regional Tribal Operations Committee, and also the Cal EPA Tribal Advisory Committee, which she chaired until recently. So a lot of involvement statewide in Clear Lake and tribes and harmful algal bloom. So we're really excited to have her today and part of the CALMS work we do. So with that, take it over, Sarah.
Thank you, Stephen.
Sorry, I should add before you get started. For everyone else, you see there's almost 60 people on. Everybody's been muted and invisible, so all that's good. And notice in the bottom right, you can see the little people icons. You can see who else is on. And the other one, the chat icon. So if you got any things you want to share or questions you've got, post them up there. And I'll be monitoring that. So if there's anything immediate, or you can post your questions and then we'll cover those at the end when Sarah's done. Okay, sorry, Sarah. Try again.
Oh, no worries. Thank you, Stephen. Can you see my screen okay and hear me?
Yep.
All right, wonderful. Well, welcome everybody. It's great to be here and great to be able to do a presentation on the Clear Lake Cyanotoxin Monitoring Program. I wanted to take you through a journey of working for a tribe and looking at and dealing with a lake that has some degradation going on and how that impacts the traditional activities that are part of Native Americans' heritage of living on the land and waters for so many thousands of years. And we have been, of course, dealing with cyanotoxins and cyanobacteria for a number of years on the lake, but I really wanted to dive into the program that the tribe has been developing over the years. I will go a little bit into tribal water monitoring programs, beneficial uses, which is also on the federal side of things under the Clean Water Act, is called designated uses. But many of you in government are probably familiar with the term beneficial uses. Some about our program, there's a lot of different routes of exposure for cyanotoxin. So we have spent a bit of time looking into the toxin levels in fish and shellfish on Clear Lake, as well as in the drinking water, particularly private drinking water systems, but a study was done looking also at public water system cyanotoxin levels. Just a bit about tribes in California. There are 109 federally recognized tribes in 34 of the 58 counties in California. There are more petitioning for recognition, and there's a number that are landless because when they were terminated by the federal government in the 50s or earlier, a lot of land was bought out from under them, and so they no longer have rancherias. In Lake County, there are 7 federally recognized tribes. 2 of them are landless. They have some presence in the county, but do not have actual rancherias or reservations. And if you think about where tribes have been and Native Americans have been in California, it's pretty much every square territory. This is a graphic of the language associated with it, and as you can see, the full area is covered. And so that means that chances are that there is a tribal group or an actual tribal government, no matter where you are in California. And that means that those traditional activities that we want to help protect in our regulations and our environmental programs, it's worth the effort because of the uses that continue to this day, that maybe the tribes aren't checking in with local government or even with state or federal government about their activities, but they certainly are conducting them in all corners of the state, which means that it's really important to understand exposure scenarios and just what that means in terms of regulations that might have to be more stringent to protect tribal uses. Tribes also, a lot of them, the federally recognized ones for sure, have the opportunity to be doing water data collection. So I just wanted to put in a little plug for that tribes are most likely doing water quality monitoring in the creeks and the lakes that are important, water bodies in general, that are important to them, where they go, where they eat from, where their medicine is, where they do their ceremonies. And if a tribe has a federal grant, they most likely have a federally approved quality assurance plan to collect that data, to track that data, and to submit that data to the federal government, EPA usually. And so this is information that is useful and is already being used by the regional boards and the 305B evaluations. And that is something that's it's worth partnering with tribes and making sure that you check and see what tribes are in the area. There's some great documents from Cal EPA about where tribes have interests throughout the whole state, and pretty much every county has some tribes listed as being interested because their ancestral or traditional territories are in those areas. So tribal data is something that does exist, and there's also the concept of data sovereignty needs to be discussed and considered because tribal data that's collected, some of it is information that tribes don't necessarily want to share, but ultimately it's a little bit different than what you see in the usual academic world of research, and just oh, you want to share it, we'll take it all. I mean, tribes really to actually collect the data and do anything with it there's a lot of obstacles that might not be in local government or in academia. So tribes not only want to be partners but leads in their work. So in 2017, after a number of years of tribal advocacy, the state actually accepted the definitions of tribal tradition and culture, and also tribal subsistence fishing. You can see this definition here. It is actually part of of documents that are now used at the state level and also being accepted at the regional level within the basin plans. And it is a way to start working on water quality standards for protection of tribal traditional uses. And as you can see, for tradition and culture, that there are a lot. It's very broad. It's broad enough for tribes to actually define it in a more specific and distinct level within certain water bodies. So I can tell you that on Clear Lake, there are multiple tribes who are working on this issue right now, basically developing the numeric criteria to protect tribal uses. Sorry about that. Oops. So I went, oh, there we go. For subsistence consumption of fish and other aquatic organisms, this is something that tribes are also very concerned about and ensuring that there's protection for it, because in the basin plans as they exist right now, there is commercial fishing and sports fish consumption of 1 meal a week is what is protected. And that is definitely not, the tribal traditional consumption of fish and aquatic organisms is, of course, a lot more than that. A Fraser-Schilling study in several years ago, which has been accepted at the water boards, brings the consumption rate from the default 17 grams per day of fish to more like 175 grams per day of fish for the Pomo area, and that is still much lower than actual subsistence consumption. For tribal culture, tribal tradition and culture, the uses that are currently protected in many of the basin plans have to do with recreational exposure. So that's swimming and being in the water for a certain amount of time and not necessarily deliberately ingesting the water. So tribal cultural ceremonies very potentially have deliberate ingestion of water, and the exposure is just it's a very different exposure. So it was important to get these definitions adopted at the state level in order to start working on actual protection at the local level. Here's a graphic that we developed for the freshwater harmful algal bloom program. And you can really put any pollution in the center. But in this case, it was because it was for the FHAB program. This is a freshwater harmful algal bloom event. And you can see that, with the graphics that with any of these traditional activities that could be happening, that there's multiple routes of exposure through ingestion or inhalation or dermal exposure. And this really does have a different look than recreation, where in a lot of cases people can, if Clear Lake doesn't look good, let's go to Highland Springs or to Blue Lakes, local water bodies where it could be avoided. With tribal traditional uses and especially, cultural activities, there's a specific place and a time when things happen. It's part of the culture. You can't avoid these locations. And so that means that people are going to be coming into contact with contaminants, whether it's cyanotoxins or elsewise. And this is because it is part of the spirituality of the tribes, and every tribe is different, how they practice it and where they go and what they do. But in general, just know that this is why it's important for tribal beneficial uses and standards that are protective of this myriad of ways where contaminants could be consumed or somehow exposed to a person during their religious ceremonies or other activities. Talk about the legacy of the toxic legacy of Clear Lake, or that was part of the title. There was recently a discussion about tribal perspectives, native perspectives in Rachel Carson's famous Silent Spring. And just the fact that, here is this fantastic book that a lot of us probably use as our, North Star or whatever. And yet there's really no perspective in that book about traditional activities and cultural activities of Native Americans who live so closely to the land, and as I showed in the previous graphic, have a myriad of ways where they could be exposed because they are doing activities that are part of their heritage, and so they don't leave parts out just because it's convenient to. And so I just really want to make that point that that Native perspectives are really important to the dialogues that we all are probably having amongst ourselves in terms of how to make this world a better place. That the Native perspective is not something that is necessarily understood in our other communities, because those are not practices and activities that we all engage in. But to have, to be working closely with tribes, help support them up, help if needed. You know, they have a sovereignty that is at a much higher level than local government, and yet, you know, they've been, you know, kind of held down for so long, and have not really had the opportunity to grow into their own. You know, the way I see it, you know, with my government background, that every tribe should be part of the United Nations and be sitting there alongside other sovereign nations in the world and make decisions about things. So when you consider that locally, when you have a poison event that takes out, you know, multiple species almost, and you know, the tribes weren't involved in the spraying of this stuff. They weren't probably not even informed of the full degradation, the long-term legacy, toxic legacy of it, the cleanup of it, or even, you know, how can we be engaged in using less toxic materials to control annoying gnats or other things like that. It should be something that tribes are engaged in and making decisions about. I did mention that tribes are working with the regional, many tribes in California are working with the regional boards to basically use the Clean Water Act to incorporate these tribal beneficial uses and the numeric and narrative criteria needed to protect these uses. This means that water bodies with TMDLs, water bodies with NPDES permits, all of these are linked to protecting existing beneficial uses and allowable discharges that would still meet the Clean Water Act requirements of protecting those uses. And just an FYI that once tribal beneficial uses are amended into the basin plans, that some of these things might change based on the more narrow protective requirements of tribes because of their multiple routes of exposure. So get ready for that ride. All right, Hobbiton is Clear Lake, and it is the largest natural freshwater lake in California. It is a pretty shallow lake, quite warm, and also considered to be the oldest lake in North America. It has many uses for the tribes. There's many plants that are located along the shoreline, not so much anymore, but you know, still some are there. It is very fertile with fish. It's known as the bass capital of the West or whatever by ESPN, I think. So just a popular place for a lot of people to go and use it. However, traditional activities are still occurring. And yet, we also have cyanobacteria blooms that are plaguing the community since 2009 and prior. But 2009, I've worked with the tribe since 2001. In 2009, it really hit us where the whole lake had a Lingbia bloom. This is Lingbia. Looks and smells like raw sewage. That is not Lingbia, that's Dolichos bramum. But, you know, it's just quite shocking to all of a sudden have a mat of noxious material that, you know, a duck, you could throw a tire on, it looks like it wouldn't sink. So this had been going on for several years, the lake looking like this, a dog death, people, you know, a stench. And two shoreline tribes, the Big Valley Band of Pomo Indians and Elam Indian Colony, decided to, you know, that we needed to start a proactive and reactive cyanotoxin monitoring program in multiple places along the lake. So you can read more about that on Big Valley's website, and I show that in a few other spots, but here's a bit.ly link for it. So in 2014, we kind of divvied up the lake and decided to do a toxin analysis, water chemistry, and a few other components. We also formed the Clear Lake Cyanobacteria Task Force, which had multiple jurisdictions engaged, and that met for at least twice a year for a number of years. It's now been, we haven't met in about 2 years now because there's other groups that have formed that are really working on mitigation measures for the cyanotoxin problems. But you know, when we first got our first analyses, lab results back, and it was, you know, in the thousands, which was obviously over any recommended safe level for recreation. We immediately reached out to all the local governments and state governments and state government and just said, you know, we need some help. There's some issues here. We're monitoring the toxins and we've got to do something about it. Of course, we are aware of the toxins that, various genera of cyanobacteria that it can produce, and that there's liver neurotoxins and skin toxins. And this is something we use in our program. We are very linked up to the state recommendations and, of course, their research. And there's just been a tremendous amount of work done by multiple people at the state in the freshwater harmful algal bloom program to not only set it up, but just the guidance that they provided over the years. And so we're very much linked up, because in looking, we do microscopy on the water samples when we get them, when we bring them in from the field, and are sending off for the specific toxins based on the genus that we're seeing, or the genera that we're seeing at the sites. So we're not just doing like all 4 cyanotoxins every time. And we've also learned over the years that there are certain the Dolichospermum genus that we really just have not seen toxins during blooms of Dolichospermum. And this is through doing qPCR analysis and other things. We're also aware of the suggested action levels that came from OEHA's document in 2012. And again, this is related to recreation and the already existing beneficial uses that have a certain assumption and presumption of exposure. And so this is why we work as hard as we do to define what tribal traditional uses looks like without revealing, sensitive cultural information. This suggested action levels also has a human fish consumption. And so the action levels are based on sports fish consumption of 1 fish meal a week. So again, we know that with subsistence consumption of fish, that these need to be recalculated for tribal traditional uses and subsistence consumption, not only of Native Americans, but there are other communities in California that are doing subsistence consumption of fish and other aquatic organisms. So we knew that, we started to see these blooms in 2009. The tribes, Big Valley and Elam, started to sample in 2014. And, we knew that the blooms also had other cascading effects in the lake, which, we had fish kills that were associated with it. Impacts on other vegetation, of course, questions about water safety, and even the fact that there's drinking water, that about 60% of the county, 65% of their county gets their drinking water from this lake, and the challenges that the public water systems had in and having to treat the cyanobacteria in a way where the toxins were not actually lysing, and making it into the drinking water, into the treated water. So there's this natural lake and the uses, it's a challenging system. And, just a wide variety of blooms. Given the fact that there's a lot of coves on the lake, there's a lot of pockets of just really stagnant waters. And so we will see mixtures of cyanobacteria, of multiple genera. And on this side, you're actually seeing a fish kill as part of it. This was actually the weekend that kicked it all off. Yeah, because of what we were seeing out there. And we're able to also do some interesting things of sampling a bloom and then also looking at it under the microscope. In this case, it was Lingbia, which has a new name now, and Microcystis. So it's just an interesting. Interesting to see what's going on in all of our sampling locations. And, we've certainly noticed over the years that the different parts of the lake will have different water quality situations going on, and blooms of different sorts. And this is all stuff that we track, as well as the water chemistry. And this is, as I mentioned, a Microcystis and the Lingbia bloom in August of 2021. So in 2014, as I mentioned, tribes wanted more information on these blooms, realized we had to start the program. We had already developed a quality assurance plans to do this. We were already prepared for that. And so the tribes went after the various funding from the state and the feds to cover our expenses for that year. And here's a little journey into a pamphlet that we produced. where it's specifically looking at the timeline of how we've started with 8 sites doing the Abraxas field strips, also sending off for lab analysis and meeting with this task force. We expanded in 2015 with a Cal EPA environmental justice grant after talking to multiple tribes to ensure that we were getting sites that were important to the tribes for gathering and recreation and cultural activities. The tribes settled on 3 spots in particular, the Big Valley shoreline, the Elam shoreline, and Keeling Park in the North Shore, to as really the 3 spots that, as long as we were sampling those regularly, providing the toxin levels, and also providing information to the tribes about the toxin levels, and doing cyanotoxin analysis prior to ceremonial events or big activities that were going on. So we were ensured that that those 3 sites would really kind of cover it. We also were started to in 2016, and this was primarily through ELM's efforts, and Corolla Kennedy, who's on the call today, doing cyanotoxin monitoring in the public drinking water system. So using the ELISA analysis equipment that she had to be starting to provide some toxin analysis data to the public drinking water systems. And that was still incorporated and folded into our program. We added some sensors to our multi-parameter probe. So we were also looking at phycocyanin, which is the pigment that's produced by cyanobacteria. And we really use that as an indicator, and we watch that. Chlorophyll A is something that there's an objective for in the nutrient TMDL for chlorophyll A. So we wanted to see, are we still having blooms with the objective such that it is, and just, using the regulatory framework to be watching to see if, the things were set appropriately. We started in 2017 to expand to a few creeks and to do cyanotoxin monitoring, particularly benthic cyanobacteria monitoring and cyanotoxin monitoring in the creeks, and started to use the qPCR method, which is basically looking at gene copy counts in the water samples and looking for the correlation of the gene copy counts and toxin levels. There's information out there about, and it really becomes very water body specific, of what's the gene copy count for microcystin producing genes that you have to have before you start seeing a detect of toxins. And Clear Lake, it seems to be very different from Klamath. Some studies that I know that Ben Genetics, which is a lab that we've been using, I believe, remember hearing that at about 5,000 microcystin producing gene copies for the Klamath, you start to see a detect, and in Clear Lake, it's more like 35 or 40,000 microcystin producing genes before you start seeing a detect of microcystin. So, so we're using qPCR as a method to keep our costs down, but also to better understand the cyanobacteria genera and what types of potential they have to be toxin producers. In 2018, in terms of really understanding the toxin levels and the impacts to tribal uses, we used a Cal EPA environmental justice grant to analyze fish and shellfish for microcystin, and we actually had about 8 years of fish to test from multiple times of the year and multiple locations, and also multiple species. I have a slide about that a little bit later, but it's just part of the development. We, really started getting engaged in the FHAB program and helping develop that. I was on some of the committees for that, and just really wanted to share our experience, because we were already at that point 5 years into a program that, we learned as we went, and really tried to refine things as we move forward. We started working with Lake County in earnest in 2020 for to get some really great signage out there, and to also track the caution, warning, and danger levels as they related to the toxin levels, and sharing that information out with the county installing the signage in multiple locations. In 2021, we had a CDC grant, which we still have today, to look at toxin levels and other contaminants in the private drinking water systems on the lake. And that has that's something we're still doing to this day, and I have a couple slides on that. And in 2022 was really more into the benthic cyanobacteria monitoring at that point. Actually, a little bit earlier, we were doing more just the dissolved toxins that were in the flow of the water. In this case, we really started looking at benthic cyanobacteria in 2022. But a tribal centric program means that the species that are being consumed and used by tribes, the locations, the time frame, even the control of the data is really about making sure that the information first and foremost is serving the tribal needs. And of course, this is all information that we're sharing and making sure that appropriate responses are happening because of what we're seeing out there. This right now, this shows a lot of sampling locations, but this is actually the full extent of sampling locations on Clear Lake. It is 100 plus miles of shoreline. We are partnering with UC Davis has had a number of these interior sites where they've been doing other studies on Clear Lake as part of the Blue Ribbon Committee for the rehabilitation of Clear Lake. So there's quite a bit of data that they're collecting, and we're partnering with them. They're giving us their water samples whenever they're out there, and then we're taking it back, doing microscopy on them, and then sending off for toxin analysis as appropriate. And there are also 3 sites in the lake that the Lake County Water Resources Department took over from the State Department of Water Resources long-term monitoring of Clear Lake. And so we're partnering with the county when they're out there doing their research and work. They're sending us back some samples so that, again, we can do microscopy and toxin analysis as appropriate. But otherwise, these are our shoreline sites, and that's we do it so that we don't have to get on a boat and get out there, and we get all of these sites in one day. Day 2, we're doing microscopy and sending off and making decisions and sending off for analysis. So we're pretty tight about it. And Elam Indian Colony was doing this with us until about 2020, and they stopped around that year. And so Big Valley is hitting all of these sites on a monthly basis during the winter and twice a month during the summer. And again, because it's tribal centric, we do our monitoring to coincide with important dates of tribal uses of the water. So I want to go into the different routes of exposure that are important to the tribe and some of the work that we've done about it. So human exposure, you could see that there's some gathering, and this is actually hitching. So this is in the creeks. That looks like our Fike net back a number of years ago when we were doing tagging and things over in the Big Valley area. And so we've got our members that are out there collecting fish and consuming that fish. We have our annual Tule Boat Festival here on the right that has a lot of children and all ages in the lake in July. So that's usually a rough time of year. So we do a lot of testing and also mitigation prior to the festival because of a lot of people getting in the water. But these are just 2 of the things that Native peoples have done for many years, maybe not the Tule Boat Festival, but certainly getting in the lake and being on a Tule boat and doing ceremonies in the lake. And the sacred Mount Canocti is in the background of this center picture. So we have, there's just a whole lot of locations that are incredibly important to the tribe and to the tribes. And we have tribes come from all over the place during ceremonies to be here, and part of the ceremony afterwards is going into the lake to wash off. So these happen throughout the year for various reasons, and the human exposure is a real thing. One thing I wanted to point about all this monitoring that we've done is that the signage that used to be there for letting people know about the lake was, if it's clear, it's fine. If it's not clear, then avoid the bloom area. And we had to prove to them that was just not the case, that the signs cannot say that, because that's just not the case. Benthic, it certainly it brings into question, but even with planktonic cyanobacteria. So in this case, we have below caution level at 0.67 for total microcystin. And yet the lake, this area, this is a sulfur bank mercury mine site. It looks like this. And in this case, you can see Corolla's boot right there. I remember this picture, Corolla's boot, and yet the toxin levels. And this is when we were using a different lab, and they were doing total. Well, the four main congeners of microcystin, and you can see it's already in the caution level and close to the warning level of microcystin. So we needed to really get the word out that yes, toxins can be present with no obvious bloom because the cells have lysed and the toxins are still there. And we all know that now, but back in 2014, we didn't necessarily know that, or it wasn't really understood. So we had to work hard to change the messaging. And, we also, this is a 2021 part of the signage tracker, we're also looking at these different sites and we know what at each of these are public parks or city parks, a couple of tribal shorelines, a couple of private properties or some of these sites. But these are all, they represent places where human activity is occurring, whether it's fishing or full immersion in the water. And you can see that in this summertime and even a little bit beyond that, in some cases, 100% of the time, it's at caution, warning, or danger. And so, with caution, you're not even supposed to be eating shellfish from that area. And so if there are people at Austin Park that like to get the clams from there, they really shouldn't do it at all during the summer. And who knows how much longer past that because of the toxin levels. So, this is some of the tracking that we do based on the toxin levels. And again, we don't always send off for toxins, but usually we are. But we're looking at the decision tree and making recommendations to actually the Lake County Public Health Officer about the signage that should go up. And the part of the messaging work group that's developed in the County of Lake with our toxin sampling is to use the jurisdictions that are here locally to make some decisions about how to get the word out to the public. And there's been a really nice collaboration going on about that. Again, some of the outreach that we do and just showing the trends of the most toxin level, most frequent toxin level for our regularly sampled sites. This is some of the outreach that we were doing back in 2021. We also have a Facebook page, Clear Lake Water Quality, and the tribe's website, bvrancheria.com/Clear Lake Cyanotoxins, where have the toxin levels. You can click on it and actually get pictures of our microscopy as well as the site conditions. Usually we will put information about, the signage that is recommended, all of the literature that's coming out from OEHA and the state about for guidance to physicians and veterinarians, and just additional resources that we want to make sure the public understands. And I have to tell you, there's just been a great educational trajectory of the Lake County community and the people around Clear Lake. They no longer call it blue-green algae, they call it cyanobacteria. I see people online correcting each other and, really informing people. And it's been a great experience, a little bit frustrating, but, we've been doing this outreach since 2015. And there's been definitely just a lot of education and additional literacy on cyanotoxins, which is good. I mentioned that we also are looking at benthic cyanobacteria in local creeks. We're 2 years into the program, so we're still refining it. There's always a lot of troubles with, the creek's already dry, and things like that. Or they stole our spat bags again. But, it's that's been really interesting to see. We're seeing toxins in the spat bags that we're not seeing in the lake. So kind of interesting. We're seeing cylinder spermopsin and saxitoxin. In Clear Lake, we're primarily seeing microcystin. So the benthic cyanobacteria research that we're doing and program that we're building in the creeks is really just, to not that there's a lot of human interaction in the creeks because it's either flowing way too fast or it's already starting to get stagnant. But there are animals that go in there, and we're looking at just the different ways that there are impacts because of the creek cyanotoxins. Of course, there are surface water intakes into the creeks as well as Clear Lake, and so we do believe that that is one of the routes of exposure is through drinking water with cyanotoxins in the creeks, so as well as the lake. So anyway, this is a program that we're building. This is a graphic. It might be a little bit hard to see, but we were comparing two creeks where I was doing a presentation to a community about the toxin levels, and really talking with them and trying to educate them on just the benthic cyanobacteria cover, what's going on in terms of erosion, the riparian vegetation, and talking to them about the toxin levels. In this case, there was a spat bags anatoxin levels of 15.18 micrograms per liter in this creek, where it is really a swimming hole of their heritage of this Anderson Creek community. Nobody was really happy about seeing those numbers. They also got really worried about, we're going to get shut down, et cetera, et cetera. But it's good to know. It's good to know, so you can take precautions and to think about mitigation measures that'll be needed to help with the situation, because it's telling you there's nutrients. You have benthic cyanobacteria, you've got nutrients coming from somewhere. What can be done to mitigate it upstream? And so just starting to track the trends of, whether the benthic cover, and this isn't a perfect, well, it is about the same amount of time, around the same time, but it does show that the benthic cover does tend to grow over the season. In terms of fish consumption, we have, again, we're looking at, there's a lot of fish consumption that the tribal members are doing. Where you see these stars is where the toxin level in the tissue is above the action level that OEHA has recommended. And again, this is based on sports fish consumption. So you can imagine that there would be a much lower level required for subsistence consumption. And here's a little bit of research on our website. You can find this. It's also in Seedon for these toxin levels. And we did do in liver, but we were particularly interested in what was going on in the tissue itself. And we did look at this study. We've got more fish that are at the lab right now getting analyzed for subsequent years. But this was 44 fish and 49 shellfish. Multiple species, and from all arms of the lake, all seasons. So we've got some interesting data on that. For drinking water, as I mentioned, there's multiple public water systems that are pulling water from the lake, serving approximately 60% of Lake County residents. And knowing that in the data that Elam Indian Colony was collecting early on, because they were offering analysis of their treated water, it did lead to an understanding that there are toxins at low levels as detected, not quantified, or even higher than that in the finished water at certain times of the year. And so knowing that and knowing that there were a lot of private drinking water systems, we did go after with a group called Tracking California for a CDC grant to look at contaminants in private drinking water systems. So these are people up to 4 service connections pulling their water from the lake and other water bodies in Lake County. And we are sharing this information with the local government and working with OEHA and the water boards on these issues. And in what we found in 2021, this picture is actually the tap water of some of the homes. So you can see intact cyanobacteria, here's Gliotrichia, oscillatoria, microcystis. And it is, we also found the highest value in the tap water. And these are people who have treatment systems. So it was an order of magnitude higher than what's recommended by US EPA as their health advisory. So this, fortunately, it's just like all worked out timing wise, that this was also the highest toxin level that had been recorded on the lake and that summer, and it was over 160,000 micrograms per liter for microcystin. And so it was like perfect timing. How lucky that we were also doing this tap water testing of the private drinking water systems. And so because of this, a public health advisory was sent out by the public health officer, Nixel. I mean, quite a few things. Basically, behind the scenes, we're all working together to find an alternate source of water for these homes, which was about 380 homes were identified that were pulling their drinking water. And actually, here's a rough map of it. These are all homes that are not part of a public water system, that have their own private drinking water systems into the lake, some of which we had tested and how we came up with that data. And so these fill stations were established from the public water systems nearby to allow, sorry, it was 280 households. But anyway, these two public water systems that had fill stations where the people could go to pick up drinking water for this time period. This do not drink advisory was out for 2 months on Clear Lake until the ambient toxin levels had reduced low enough that I mean, probably could have stayed on for longer, but it had reduced quite a bit by within 2 months. There's now been a study comparing the public water systems. I'm a co-author for, it came because of our CalWatch project. So there's a number of us on there, with the lead being Rebecca Stanton, and Amy Little. So Becky Stanton, who was with OEHA, now at CDPH, and Amy Little, now Sydney Little, who was at the water boards, and we were looking at, ambient toxin levels, the private drinking water system levels, and the public water system toxin levels. So it's a great document. Please take a look. And really, we definitely see a relation between the toxin levels in the ambient water on the shoreline, and of course the private drinking water systems with the public water systems. Again, there's many of them were detected, not quantified, but I believe the highest that came about because of the order that the water boards established for the summer of 2021 for the public water systems. There was I think the highest toxin level was a 0.2 in one of the public water systems treated water. So almost at that 0.3 health advisory level of EPA. In the CalWatch project and the morbidity and mortality weekly report, we did report on the different types of treatment systems that all of the participants that were part of our CalWatch project had, and what the toxin levels were, or whether a microsystem was detected or was above that health advisory. So you can see that, even with ultraviolet disinfection and various types of filtration, that microcystic can still be detected. We did not detect any cyanotoxin for any of the wells that were near shore, however. So, another part of our CalWatch project is just the analysis and surveying that we did of the uses of Clear Lake, and how harmful algal blooms, how it's impacting the different uses that are happening on the lake, and also people's input on whether they've had health issues with themselves or their pets. So that is also on Big Valley's website, or you can go to info@trackingcalifornia.org. We're also working with tribes throughout the state, and actually the Region 9 EPA, to help them start their own cyanotoxin monitoring program. We've had 2 of these workshops so far, have a third one planned for May. And it's a week-long training that we do with tribes. And it's funded by BIA, and also a little bit from the Bay Area Council with one of our projects, one of our grants. Here's the signage that Lake County came up with, and all of us came up with. You can see our logos, and it's the QR code links to Big Valley's website with the toxin levels, and it's great. It's transparent. It's honest. It's saying, be aware. And here's some more information on how to report a bloom, how to get in touch with the county, and also to look at current toxin levels. And that is the rest. That's the end of my presentation. Thank you very much.
All right, thank you, Sarah. I guess we have time to take some questions. You can either type it in the chat, or I see someone with their hand up. So Frank, if you have any questions, just unmute yourself, or
Thank you. Good afternoon. I apologize, I jumped on a bit late, but will participants get a copy of the presentation?
Yes, I was saying it up front. We'll post a link to this video once it's recorded. It takes a little while to do that, but you'll get a message maybe in a week or so.
Excellent, excellent. I appreciate it. Thank you.
Sure.
And Stephen, I'll put my email in here, and if it's okay, if people want to email me and get a copy, you know, a PDF of this, I'm happy to do that as well, if that's okay.
Yeah, no problem at all. So yeah, and thanks, Sarah. That was fantastic. There's so much information going on there. It's such an important lake for the region. And oh, there you go in the chat. She's got her email. You know, it's had a lot of problems. So it's worthy of all the work that it gets. So thanks for all that effort. I had one. You're talking about you know, sort of collaborating tribes and other jurisdictions and whatnot. The work that YSI presented at the beginning as part of the sponsor sort of message, is that tied into your work at all?
Yes, we actually worked with Dave Karen when he came out. I mean, just, you know, support work really. But we did share our information about what we had been seeing out there. And actually, Dave was part of the 70-year perspective document. And I'm sorry, I didn't put the link in my presentation, but we did hire Squirp in USC to do to evaluate our data. We shared all of our cyanotoxin or our cyanobacteria information that we had, like all of the microscopy that we did and our toxin levels. And so they did a really great evaluation of the trends. And I know that Dave's group were able to dig a lot further into it in terms of you know, looking for the drivers in the lake. And so, yeah, we were pleased to partner with them and support them in their efforts.
And one of in looking at the chat, somebody was asking for that bit.ly link. If you have that easy, it's in the presentation. You can catch it later once the recording is available. But if you can post that, that'd be great.
Yes.
Other questions? I can keep asking them if nobody else does. One, and so post some, and it is just a couple minutes before noon. How are you doing on time, Sarah? If people have some other questions and want to keep chatting for a minute, can you stay on for a few more minutes?
Yeah.
Okay, great. So one other question is, the data you were sharing and all was maybe what, a decade or so back. What about the longer term trends? How much is known? I mean, some of the stuff with the toxin analyses is fairly new, but you know, San Francisco was looking for water and they ended up turning away from Clear Lake nearby and going to Hetch Hetchy because it wasn't such good quality, you know, 100-something years ago. But you know, that was based on less information. What's your understanding of the long-term trends about it, you know, how it's getting worse or what?
Well, you know, it's interesting that Lake County did work with University of Santa Cruz or UC Santa Cruz, and they had multiple locations on the shoreline in 2011, multiple locations on the shoreline and in the interior of the lake. And I believe the highest toxin level that they saw, they were mainly, you know, they were enumerating the cyanobacteria because, you know, a lot of times or earlier that seemed to be the thing, or how many cells per mil, and basing the guidance on exposure based on that. But they did do some toxin analysis, and the highest toxin level for microcystin in 2011 in the study that was done was 29 micrograms per liter. So you know, if you look back, you know, certainly the Clear Lake nutrient TMDL has been in play for a couple of decades on Clear Lake. So there was obviously an understanding of nuisance algal blooms, and certainly studies that were done and how to mitigate for them through UC Davis and others. Causes and control of algal blooms, for example, was I think finalized in 1994. Yet I don't think the understanding of the toxins were really, it wasn't really a thing until later, as far as I can tell in the documentation for and basically the management of the lake. We know that the World Health Organization in the 90s came up with some recommendations for drinking water levels and for recreational levels. So that kind of came about in the 90s. And so again, yeah, the highest toxin level that was recorded on the lake, as far as I know, was in 2011, and it was 29 micrograms per liter. So when we started monitoring in 2014, we were already seeing almost 17,000 micrograms per liter, about 100 feet from a drinking water intake, and that was at Clear Lake Oaks. So something happened during that time. There was a dog death in 2013, and I believe the ambient toxin level was about 300 micrograms per liter. So I do think that the genera has changed. So the dominant genus in 2009 was Lingbia, and that does not seem to be a toxin producer. We've noticed that certainly has other impacts. Primarily when we are seeing Microcystis species, that's when we know we're going to have high toxins. So I think as long, and there are a lot of nitrogen fixers that are that dominate early on in the season, and they can hold on for a while. It seems like the nitrogen fixers are not toxin producers in the lake. That's what we're seeing. Although there's some, sometimes that's not the case. But if the nitrogen fixers can hang on for a little while, and Microcystis comes late, it tends to be a lower toxin level. As a matter of fact, after the Valley Fire in 2015, we had just seen really high toxin levels on Clear Lake and Microcystis bloom really forming, and this was in August. And then the fire happened, a series of fires happened. We did not see any more cyanobacteria in the lake that year. We only saw diatoms, and the toxin levels for the rest of the year were no detect. And then the following year, we saw nitrogen fixing genus Dolichospermum be the dominant genus throughout the whole year. And the highest toxin level the whole year following the Valley Fire was highest was 0.67 micrograms per liter. So, we're seeing some really interesting things because of the fires and big changes, but it does seem to be the key is to keep the nitrogen fixing cyanobacteria in there as long as possible. Because once we start seeing Microcystis, and that's really been the dominant genus for a number of years, it will then we'll see those high toxin levels. But in 2009 and and those years where the blooms really started in earnest, when we were seeing a lot of Lingbia, the toxin levels seem to be non-detect or quite low.
Got it. All right, thanks. And then you see in the chat, David Karen posted a link to the review that you were mentioning.
Thank you. Great.
And the YSI's white paper too, a little more condensed, I suppose. Any other questions? I saw a lot of people figure out how to use those little icons that are flashing across the screen, thumbs up and all that. So thanks for sharing that.
Yeah, I didn't put the bit.ly link in, but if you go to the Clear Lake Cyanotoxin, the bvrancheria.com/Clear Lake Cyanotoxins page, you'll see our data, and that's where the 2-page programmatic bit.ly link is, as well as that graphic that I showed on tribal exposures and things like that.
Yeah, got it. Any other questions? See, people are falling off a little bit. It's 1 o'clock. That's kind of get back to work time for many.
Well, thank you so much. Really appreciate having the opportunity.
Yeah, you bet. Thanks again, Sarah. It's great to see this work, and hopefully we'll see some presentations on this or abstracts coming up for the NOLMS conference in November. Be a good topic for that one.
Definitely. Thank you.
All right, take care, everybody, and look forward to some messages with a link to this, so you can rewatch it if you want or share with anybody, and then announcements for the upcoming webinars the next 3 or 4 months. We've got other ones lined up. That was a great kickoff, Sarah. So thanks for that.